Hi, my name is Ralph Deters, and this talk is about using blockchain technology to enable sharing of resources in cooperative environments. It is joint work with Sandra Kumi, she's just like me, from the University of Saskatchewan, and Richard Lamotte, he's a professor at Penn State, US. Sandra is, just because she's not here, here's a picture. She's a PhD student. There's a picture of Richard from Penn State, and here is an older picture from me. So this talk has two primary goals. It is to talk about data sharing in data cooperatives and the use of blockchain technology there. And it's also an attempt to highlight the strength of blockchain and distributed ledger technology to enable process-oriented coordination, which is very useful in distributed environments. The talk is organized as follows. I will first talk generally about data sharing, go a little bit about existing data sharing paradigms, talk about blockchain technology-driven approaches, and then talk about smart contracts and process coordination, which is kind of our approach, and then talked hopefully about some examples. So data sharing the cooperative management of resources is essentially, like shown here. You see a couple of data stores, and these are owned by various organizations or individuals, and they can all share and therefore have the benefit of combining the data to achieve something. Now, it's of course important to realize that data sharing is, you most often have, of course, some computational processes. So you've got somewhere an environment in which you run programs, and these programs interact with your local data stores and the ones that you have access and which belong to others. And the key question now is how to enforce policies that govern the cooperative management or cooperative sharing of resources. And the key challenge is here you don't have a central control. And generally speaking, there are many aspects. You focus on access. Who can access? Duplication. Where is my data duplicated, or do I not allow duplication? What are the operations that are allowed to be executed on the data? And so how to coordinate access, storage, and usage is very, very important. Now, this is a very well-known problem, and people have been working on this or exploring this quite actively right now. There are many approaches, and the key thing, I think, is to focus on the locus of control, who decides. There are many, many different approaches towards this. The easiest example is you have a contract with someone. An alternative is you have an agent that on your behalf establishes contracts. You can go into a data cooperative. This is the model I will be focusing on in this presentation, which I like very much. That is, people come together, share their resources, and when they don't want to collaborate anymore, then they go and take their resources with them. There are data commons, which are similar to data cooperatives, except when you leave, you can't take your data with you. You don't have to give new stuff, but what's there stays there. There's the data trust, where you establish an infrastructure that is owned kind of by a third party or the community, and that now controls how things are done. And finally, data institutions, organizations that act on kind of agreed upon typically public interest, and manage your data. So you can see there are different levels of where you are still in control. And this talk focuses more on data cooperatives, which I think are one of the most interesting approaches. Now, within this various different paradigms, it's important to point out that more or less right away with the arrival of blockchain technology, people realized its potential for solving some of the aspects of this problem, especially out of the IoT community. And there you can see early on that people focused on capability-based control. So blockchains allow us to exchange tokens. So let's use these tokens, and the tokens determines what the holder of that token, the process, the organization, the individual can do with certain resources. Of course, this has also been extended to use smart contracts, which control, generally speaking, the access. And that's fine. And they're all great. They only have one problem, latency. And that's the big one, because of course, if you have blockchains or distributed ledgers, they're decentralized, they're supposed to be scalable, secure. Well, latency is an issue. We originally worked with Kaleido, which is a blockchain as a service spin-off from AWS, as far as I recall. It's not only quite pricey, it also has a certain latency, 5 to 6 seconds, which we did in some of the experiments of what we always measured. Hyperledger, you can have a little bit larger, and Ethereum, of course, significantly higher. So the goal then is, if you have this high latency, then you probably don't want to make all the decisions in your smart contract. You want the smart contract more as a coordination, as a management component higher up. And so we fall back in our research to a very old concept that programming is computation and coordination. So we split the computation and the coordination. Coordination is organized by the smart contract. The coordination takes place in containers like Docker containers. So coordination, the more well-known approaches are the data-oriented ones, shared memory like Linda tuple spaces. And in process-oriented ones, we're very close to the work of Arbab, who was on Ideal Worker, Ideal Manager, and we tuned it a little bit. So the smart contract assumes that all computations take place in containers, Docker containers. We can control what the programs in these containers can do, like lightweight virtual machines. We control the inputs and the outputs, the access to the file system. And the only thing the containers actually we allow them is to send events to the smart contract that then trigger behaviors. So the smart contract soft wires everything. And it's very nice. Now I have very good control over the various computations, and I can right away disconnect someone. And of course, I also use the concept of proxies, because, if you have significantly large data stores, you're not going to hand over the store. You're going to generate proxies, a skeleton, and a proxy on the client side, they generally called stub. And then you have these two entry points, and you can control them. And the smart contract can now detect, how is someone using a data source, because the proxies can report it. And by configuring the proxies, you can then therefore disconnect if there is any abuse. So the blockchain technology allows us to configure, reconfigure, terminate the containers. And we use events from the data owners, say something funny is going on with my stuff, the data consumers, hey, I'm not getting what I actually paid for or I want. And you have monitor components that just see if there are any anomalies. They all generate events, and the smart contracts can therefore then change the system. And we, of course, can use the logging features. In our implementation, we very much rely on that all user interactions, data uploading, which is important in citizen science, and controlling how it is used is done via mobile apps. So we have a very good grip at that point. We assume all data stores are cloud-based, RESTful, like we use Firestore, Firebase. We will assume that all software runs inside of Dockerized containers. Can also be other container platforms, but containers are the ones which are important. And we use the Google Cloud platform. And we also assume the proxies are cloud-based. Blockchains, we started working originally with blockchain as a service from Kaleido. I love just paying for a service. It was too expensive, and we switched to Hyperledger. Let's go quickly to the example. So in the citizen science, which essentially you're looking for volunteers, We worked in collecting information for the water, the Saskatchewan River Delta, wildlife plans. So people use smartphones to upload the information there, and they can always see how it is used, and they can say, no, I don't want my data anymore to be used. Farming is similar, except there a lot of conditions are attached, like my competition is not allowed to know it. And we also did things in the realm where we have to implement OCAP, and that was about ecotourism on indigenous land, where you not only have the people that provide, but you also have First Nation to control things. And then it was also in the context of Cree learning. So I think my time's up, and so I'll stop here.